we will try to understand a demonstration on dimensionality reduction and visualization by principal component analysis with MNIST data set. Let me go to Jupyter notebook. This is my Jupyter notebook. I collected data set from famous website kaggle.com. These are the required libraries we need to demonstrate this particular program. My training file name, my data file name, let me say data file name. This is train.csv. I am reading this particular file with the command read_csv. This data file is get stored in an object known as d0. Let me check the data stored in d0. d0.head5 means it will get it will display first 5 rows in this particular object d0. In this data file, I have a column known as label column. I am collecting that label column in a variable known as L. I am dropping label column from this data file by drop command and keeping all other columns in a variable known as D. Just that's what it says. If you observe carefully, these are the column names. Label is my first column name. Pixel 0 is second column name. Pixel 0, pixel 1, so on. Just see, if you observe here, you have pixel 783. Means pixel 0 to pixel 783 means there are 784 columns and another column, label column. Therefore, totally there are 785 columns. As we were saying that head 5, it is displaying first 5 rows and 780 columns. I already collected data in a variable D. Let me check this one. It is some sort of sanity check. I am checking the shape of D as well as shape of L. If you carefully observe, D dot shape means in this particular data file, I have 42,000 rows and 784 columns. In this L variable, I have 42,000 labels. For each row, I have a label. All those labels I collected in a variable L. This one is a simple and straightforward demonstration. First, let me visualize this 2D data, 2D visualization using PCA. What am I doing? If you observe carefully, here I have 42,000 rows and 784 columns. Instead of working with that 42,000 rows, I am collecting a sample of data. From that labels, I am collecting from 15,000 labels and I am collecting 15,000 rows. Means instead of working with that 42,000 sample data or 42,000 data size, I am collecting only 15,000 samples. Only for simplicity we are doing. Calculating eigenvalues and eigenvalues is a non-trivial task. In order to simplify the task, I am collecting 15,000 data set size. Even if you want, we can work with that entire 42,000 data set also. First, let me pre-processing this one. This is known as data pre-processing. In data pre-processing, there is something like column standardization. Just let me do column standardization by using this particular library. This library name is known as this is standard scalar. This is available in sklearn library. Sklearn is one of the beautiful library available in Python programming language. After standardization, which one am I standardization? I am standardization data. In data, I have 15,000 rows. That one I am standardizing. After standardizing, again I am checking the shape, whether it is having same shape or not. Yes, it is having same shape. Still, it is having 15,000 rows and 784 columns. Of course, this data is standardized data now. Now what I am doing, the standardized data is stored in a variable known as standardized underscore data. That one I am storing sample underscore data. Now what am I doing? This sample underscore data dot t means it is a transpose. I am multiplying a transpose into a. If I multiply a transpose with a, what will I get? I will get covariance matrix. There is NumPy module. In NumPy module, we have a command, we have function known as matmul function. With the help of matmul function, I am multiplying a. This is sample means it is just like a. Sample dot capital T means it is a transpose a. I am multiplying a transpose with a so that I will get covariance matrix. We are storing that covariance matrix in a variable known as covar underscore matrix. Let me check the shape of this particular matrix. Just I am typing that particular shape. What am I getting? This covariance matrix shape is 784 by 784. Now there is a function EIGH in SciPy library. This is useful for calculating eigenvalues and eigenvectors. This is EIGH function. I am calculating eigenvalues and eigenvector for vectors for covariance matrix. This matrix order is 784 by 784. Therefore, it must have 784 eigenvalues, 784 corresponding eigenvectors. My intention is I must project this data from 784 dimensions to 2 dimensions. Therefore, what am I doing? I am taking top 2 eigenvectors. That top 2 eigenvectors can be treated as principal components. This is 782 and 783. I am calculating last eigenvector. 783 means this is top eigenvector. 782 means next top eigenvector. I must set top eigenvalues corresponding eigenvector is 783's eigenvector. Next top eigenvalues corresponding eigenvector is 782 eigenvector. As this function returns eigenvalues in ascending order, of course it will also return corresponding eigenvectors in ascending order. These eigenvalues will get stored in a variable values. Corresponding eigenvectors will get stored in a variable vectors. Now vectors dot shape means just I am checking the shape of my eigenvectors. If I just let me run this simple code, let me check the shape of my eigenvectors. This just see vectors dot shape means 784 by 2. Shape of my eigenvector is there are 784 rows and 2 columns. Column 1 is first eigenvector, column 2 is second eigenvector. I have to project these 784 dimensions into 2 dimensions. That's why I collected top 2 eigenvectors. After that, I am taking transpose of eigenvectors. What is the necessity of taking transpose? In order to accommodate matrix multiplication, I am taking transpose. Just I am printing shape of that particular matrix. Again, as we are taking transpose, it is printing as 2 by 784. Now what I have to do? Now these are the vectors. Vectors means I have top 2 eigenvectors. My idea is these 784 dimensions must be projected into 2 dimensions. Therefore, vectors is having top 2 eigenvectors. That 2 top eigenvectors I am multiplying with my sample data. NP dot in NumPy there is a function known as matmul. With the help of this function we are multiplying. If I multiply, now just let me run. Just see this output. What it says, just see resultant new data points. Vectors dot shape. What is the shape of my vectors? As we discussed, 2 by 784. And what is the shape of my sample underscore data? 784 by 15,000. If I multiply these 2 matrices according to matrix multiplication, number of columns in first matrix must be equal to number of rows in second matrix. Therefore, my resultant matrix order is 2 by 15,000. What does it mean? My 784 dimensions we converted into 2 dimensions. There is something like VStack function. VStack means vertical stack function. for that particular function. Now this 2 by 15,000, this is order of my resultant matrix. This 784 dimensions is converted into 2 dimensions. This particular matrix is get stored in a variable is known as new underscore coordinates. Just see, this is new underscore coordinates whose size is 2 by 15,000. What does it mean? Just see. Now what am I doing? This new underscore coordinates with this matrix, I am appending labels. What are the labels in MNIST dataset? We have 10 labels 0 to 9. Therefore, in this particular new coordinates table, I have 3 columns. Earlier we had 2 columns. As I am appending label and I am taking transpose with for this particular new underscore coordinates, I am creating a data frame. Just if I create a data frame, how can I create data frame? By giving this particular data file. And what are the column names I am giving? I am giving first principal, second principal, label. First principal means first principal component, second principal means second principal component. Just I appended label. Why am I appending label? To give color coding. While visualizing data, I need color coding. In order to accommodate color coding, I added this particular label column. Earlier, we had only first 2 columns, first underscore principal, second underscore principal, isn't it? Now we added one more column, third column, that is label column. This facet grid function is useful to display this particular data frame. What is my data frame name? My data frame name is just data frame. After calculating data frame, what am I doing? I am using Seaborn. It's a data visualization library in Python programming language. By using hue parameter, it is useful for giving color coding for the labels. What are the labels here? We have labels 0 to 9. There are 10 labels in this particular data set. Which plot I am keeping? I am keeping scatter plot. If you observe this one, this is my output. Where is my output? Just see. Let me minimize. Let me reduce the screen size so that it will be visualized in maybe more cleaner manner. Just see. This is my first principal component on x-axis, second principal component on x-axis. What are the labels? There are 10 labels from label 0 to label 9. This is label 0 data. Just if you observe carefully, this is my label 0 data. If you observe carefully, this is label 9 data. There is a clean separation in between label 0 and label 9, isn't it? Now, let me use this particular, this is a simple illustration how one can illustrate this data visualization. Even if you want, we can reduce its dimensionality. How can I reduce its dimensionality? Even we illustrated this data visualization by reducing dimensionality only. Actually, there are 784 dimensions. Now we projected that 784 dimensions into only 2 dimensions. After projecting into 2 dimensions, what we did, we visualize the data. Why? Because in 784 dimensions, it is difficult to visualize data. Therefore, we converted it into 2-dimensional data and we visualized. After that one, even you can make use a concept known as eigenvalues. What is the use of eigenvalues? Eigenvalues are useful for explaining the variance, or otherwise I can say for explaining the spread of the data. How data is spread, how much percentage of data can be retained, how much percentage of data can be preserved. That is the basic purpose. That's the basic purpose of eigenvalues. This is a simple demonstration for eigenvalues. If you observe carefully, just see, this is a plot. I plotted. I am taking components on x-axis and cumulative explained variance on y-axis. What does it mean? Let me assume I am taking components on x-axis and cumulative explained variance on y-axis. out of 784 dimensions, let me say we are considering some 100 dimensions. 100 dimensions means just see this point. 100 means it is this corresponding point on this curve is in between 0.6 and 0.8. Let me say it is 0.75. Means out of 100 eigenvalues, if I consider first 100 eigenvalues, corresponding eigenvectors, if I project by using first 100 eigenvectors, I can retain 75% of the information, 75% of the variance. Otherwise, let me say if I take out of 784 eigenvectors, if I consider some 350 eigenvectors, it is approximately 0.95. What does it mean? 95% of information can be retained by principal component analysis algorithm by just considering 350 top eigenvectors. Thank you very much.